Hello everybody, welcome to Network Soup. I'm your host Kaz Campbell, and today I'm going to take you through IPv4 addresses in less than 5 minutes. So let's get started. So to begin, we need to understand what an IPv4 address is. Well, first, the IP portion stands for Internet Protocol, and the V4 is for version 4. IPv4 was first deployed for production in 1982. And at the time of this video release, IPv4 still routes most of the internet traffic today. However, IPv6 is quickly taking over. IPv4 is expected to die as a functional protocol by 2040. So a couple other things to keep in mind. IPv4 uses the 32-bit address space, which provides 4,294,967,296 unique addresses. While that sounds like a lot, think about all the devices today, all the smart devices we have, all the different computers, all the phones and other stuff that's out there. That address space, it's really not as big as it seems, and that's the problem with IPv4 and why it's going to eventually be phased out. It's also important to know that out of the 4 billion addresses, a large block of them are reserved for special networking methods and needs. It's important to understand too that IPv4 is a logical addressing system. If you watched my video covering MAC addresses, we discussed that MAC addresses are physical, IP addresses are logical. So what's the difference between the two? Well, think of it like this. MAC addresses are more or less burned into the device itself. It's static, it's not going anywhere, and it's not supposed to change. Logical addresses, on the other hand, are not burned into the device. There is no one specific IP address that comes with your device, and it doesn't physically exist on the device itself. It is virtually created, and therefore is considered a logical address. Now that we've got some of the basics out of the way, let's look at some other IPv4 considerations. Now, I'm not going to be able to go into extreme detail on each one of these topics. In fact, I could probably make a whole video on each one of these things alone. But let's go ahead and run through some of these concepts and at least get you familiar with their existence. The first thing that I wanted to bring up is public and private IP addressing. As I mentioned earlier, the IPv4 address space quickly became very limited. As a result, public and private IP addressing was introduced. So what is it? Well, think of it like this. A public IP address is used to uniquely identify your device on the internet. A private IP address is just used within your local network. To utilize this, we use something called NAT, Network Address Translation. NAT allows you to use many private IP addresses on your network and point towards a public IP address that you've been assigned that will then go out and talk to the internet at large. At least at a broad level, this is what it does. The next couple things I would like to cover are CIDR, which is classless interdomain routing, as well as subnetting. At a high level, what these two things are capable of doing is breaking down networks into smaller chunks. So now that we're familiar with these new terms and concepts, let's take a look and see how IPv4 addresses are organized and how they are put into address classes. Now, I'm not going to be able to spend as much time as I'd like to going over each one of these IP address classes. What I recommend doing at the end is pausing the video and making sure that you know the class A, B, and C public and private IP ranges. Some other addresses that you should know are loopback addresses, and they are within the 127.x.x.x range. Also be aware of automatic private IP addresses, also known as PIPA addresses, and those are in the 169.254.x.x range. And last but not least, know that there is a Class D and E range, and that Class D is used for multicast networking, and the Class E range is reserved for future or experimental uses. Alright everybody, there you have it. A brief overview of IPv4 addressing and how it all works. I hope today's video has given you a better understanding on this topic. If you liked today's video, don't forget to like, share, and subscribe. And of course, have a great day.